La Nina has reached its peak strength, but its influence lingers, especially as we experience a significant stratospheric warming event. These two phenomena are merging, creating a unique atmospheric scenario over North America. The interaction between La Nina's cooler waters and the warming stratosphere can lead to unpredictable weather patterns, affecting everything from precipitation to temperature. As we look ahead, the potential emergence of an El Niño later this year adds another layer of complexity. El Niño typically brings warmer ocean temperatures, which can drastically alter winter weather patterns. The ENSO cycle, shifting between these warm and cold phases every 1 to 3 years, plays a crucial role in our climate. Monitoring these changes is essential, as they can significantly impact seasonal forecasts and our daily lives. The interplay of La Nina and stratospheric warming is a fascinating dance that sets the stage for what's to come in the 2025/2026 weather seasons. Temperatures play a crucial role in determining snowfall potential, especially during El Niño winters. In these years, we often see increased snowfall in the eastern and southern United States, as well as the central and upper plains. This is largely due to low-pressure systems that sweep across the southern United States, bringing in more moisture. When that moisture meets colder air, the chances of snowfall rise significantly. However, the deep southern United States typically sees less snow because it just isn't cold enough. Interestingly, the higher elevations in the southwestern United States often experience much more snowfall during these winters. On the flip side, regions like the Great Lakes, Northern Rockies, and the Pacific Northwest usually get less snow. This pattern isn't random. It's a reflection of how certain global factors can consistently shape our winter weather. Just like in math, where 1 plus 1 equals 2, the weather can reveal predictable outcomes based on these dynamics. El Niño significantly alters winter weather across North America, primarily by influencing the jet stream. Picture this, a powerful river of air flowing high above us, around 8 to 11 kilometers up. During an El Niño event, this jet stream shifts, creating a low-pressure area in the North Pacific. As a result, the subtropical jet stream strengthens over the southern United States. This means cooler temperatures and increased moisture for the south, leading to a higher chance of snowfall in the central and eastern regions. Interestingly, while the southern half of the United States experiences these colder conditions, the northern states and southern Canada often enjoy warmer than normal temperatures. The temperature anomalies from past El Niño winters clearly show this pattern. So, when El Niño strikes, expect a winter of contrasts, snow in some areas and unseasonably warm weather in others. It's a fascinating dance of atmospheric forces that shapes our winter experience. The latest European Center for Medium-Range Weather Forecasts, Ocean Forecast, is showing intriguing signs of a potential El Niño emerging for 2025 to 2026. We're witnessing a warm area spreading across the eastern tropical Pacific, while those cold anomalies are fading away. This isn't an official El Niño yet, but it's a crucial indicator. As we move into summer, these patterns are typically precursors for a developing event later in the year. The long-range ensemble forecast reveals that La Nina conditions, which have dominated recently, are expected to vanish by spring. What's fascinating is that many ensemble members are projecting a shift towards warm anomalies, surpassing that critical 0.5 threshold for El Niño. The Physical Science Laboratory's extended analog forecast highlights this transition, showing the cold phase weakening and the likelihood of an El Niño event increasing significantly by late 2025, with even higher chances in 2026. This could have profound impacts on global weather patterns, so it's definitely something to keep an eye on. You can see a high-pressure anomaly developing in the stratosphere, making its way down as we approach mid-March. This is significant because it's starting to connect with the surface, and we know that pressure and temperature anomalies take time to influence lower levels. Typically, we expect to see weather impacts in the 0 to 30-day period following a sudden stratospheric warming event. The latest 30-day pressure forecast reveals a high-pressure area in the Pacific, influenced by La Nina, alongside blocking high pressure over Greenland and the polar regions due to stratospheric warming. This combination sets the stage for a low-pressure anomaly over Canada and the United States. As we transition into early spring, this pattern often leads to cooler conditions across the United States, with the potential for snowfall in northern areas. The temperature forecast reflects this, showing colder than normal temperatures for the western United States, while the eastern regions also experience cooling from these atmospheric shifts. It's a fascinating interplay of forces that shapes our weather. La Nina significantly influences our atmosphere, especially during winter and spring. Picture this. A high-pressure anomaly in the North Pacific creates a low-pressure area over Canada and the northern United States. This setup allows colder air to flow southward, leading to below normal temperatures in the northern regions while the south experiences a warm-up. But it's not just La Nina at play. We're also witnessing a sudden stratospheric warming event. This phenomenon is crucial as it disrupts the polar vortex, causing a stratospheric high-pressure system to dominate the polar regions. The result? A dramatic shift in weather patterns that can ripple down to us. As we look ahead, the interplay of these atmospheric forces will shape our spring weather, making it a fascinating time to observe the climate dynamics at work. A sustained westerly wind burst in the eastern ENSO region is creating a significant warm ocean anomaly, and forecasts suggest this pattern will persist for at least 2 weeks. Beneath the surface, the dynamics are fascinating. The cold pool from the active La Nina is concentrated in the central Pacific, reaching depths of about 150 meters. However, a warm anomaly lurks deeper to the west and at the surface to the east. This indicates that the surface warmth isn't deeply rooted. It's primarily influenced by the current westerly winds rather than a fundamental shift from below. Understanding these anomalies is crucial, especially as La Nina can continue to impact weather patterns into spring, particularly if the polar vortex gets involved. The interplay of these elements can lead to unexpected weather events, making it essential to keep a close eye on these developments. The ocean temperature anomaly in the ENSO 3.4 region has taken quite a turn since mid-December. We witnessed a significant drop, plunging below the -0.5 La Nina threshold, marking its lowest point. However, since late February, a warm anomaly has emerged in the east, signaling a shift. If we look at the broader picture, the ocean surface anomalies reveal a dramatic cooling across the central Pacific from November to February. But just 2 weeks ago, that cold anomaly started to fade, particularly from the east. This cooling was largely driven by the easterly trade winds, which you can see in the wind anomaly graphic. The blue areas represent those cooling winds, while the yellow and red indicate a westerly shift pushing for warming. It's a fascinating dance of climate forces at play. During an El Niño, we see lower pressure over the tropical Pacific, leading to increased rainfall and storms in that region. In contrast, La Nina brings higher pressure, resulting in stable conditions and fewer storms. These shifts in pressure significantly influence global weather patterns over time, impacting seasons in both hemispheres. Currently, the ocean analysis reveals colder than normal waters in the central Pacific, a hallmark of La Nina. However, an unusual warm anomaly is emerging in the eastern region. Since early December, a stronger cooling phase has been evident, creating those distinctive cold wave shapes caused by trade winds pushing surface waters. Yet, the growing warm anomalies in the eastern ENSO region, driven by westerly wind anomalies, signal the decline of La Nina. Despite this, the central Pacific still maintains a robust cold area, showcasing the complex dance of our planet's climate system. The El Niño Southern Oscillation, or ENSO, is a fascinating phenomenon in the Pacific Ocean, swinging between warm and cold phases every 1 to 3 years. Picture this. The Niño 3.4 region, the heart of ENSO, influences global weather patterns significantly. When we experience La Nina, the cold phase, we see high pressure dominate, leading to cooler, wetter conditions in some areas. Conversely, El Nino brings warmth and low pressure, altering rainfall and temperature across the globe. These shifts typically develop from late summer to early fall and can last until spring, but some phases linger for years, reshaping climates and ecosystems. Understanding ENSO is crucial as its impacts ripple through weather systems worldwide, reminding us of the intricate connections in our atmosphere. La Nina has just passed its peak strength, but its effects are far from over. As it merges with a current stratospheric warming event, we're witnessing a fascinating interplay that will shape weather patterns across North America. The Pacific is a dynamic place, and these large-scale ocean changes are crucial. They influence everything from temperature to wind patterns, creating ripples that affect our seasons. As we look ahead, predictions suggest an El Niño could emerge later this year, potentially transforming the winter of 2025/2026. This oscillation between warm and cold phases in the Pacific, known as ENSO, typically shifts every 1 to 3 years, and its impact is profound. Understanding these patterns helps us prepare for what's to come as the climate continues to evolve in response to these oceanic anomalies. The interplay of La Nina and stratospheric warming is just the beginning of a complex weather story unfolding before us.